Hi everyone, so today we are going to be solving exponential equations using logarithms. So there might be a time when we can't write each side of our equation with the same base. So what we will need to do is we will need to go ahead and rewrite the equation in logarithmic form. So we do this in order to get the x, or the variable, out of the exponent. What you will need to remember is our change of base formula. So at times we might need to use our change of base formula in order to calculate a logarithm. So let's look at these examples together. So in the first equation, what we have is our base of 4 to the x power is equal to 15. So we will need to rewrite our exponential equation in logarithmic form. So we do our loop, and so we rewrite this with the log with our base of 4 of 15, which becomes our argument, which is equal to our exponent, which is the x. So what we can do is we can go ahead and do the change of base formula. So we have log of 15 over log of 4, and that would get us 1.953, rounding to 3 decimals. Now in our next example, we do have 5 to the x plus 2 is equal to 22. So let's go ahead and rewrite in logarithmic form. So we have the log of our base of 5 of 22 is equal to that exponent, which includes together the x plus 2. So we can do our change of base formula on the left-hand side. So we have log of 22 over log of 5. And remember, we can simplify that. So we can go ahead and write 1.921. And remember, we got to solve for x, so we will have to subtract 2 from both sides, which is going to get us an answer of negative 0.079. Now, with this example, you do see that you have that negative 2 in the front. So we will have to undo that negative 2. Now it's not going to be adding 2. We're actually going to divide by negative 2 because it is multiplication, which gets us on the right-hand side of a positive 20. With this, we've got our logarithmic form we could rewrite as. So log base 6 of 20 is equal to 2x. You can do the change of base formula, which will get you 1.672. Remember to solve for x, so divide both sides by 2, and you get 0.836. Now, this process that we use to solve exponential equations can also be used to solve application questions, especially ones that have interest. We looked at these problems earlier in our unit. So let's look at this example. This problem is actually one that we did before at the beginning of the unit when we had Spencer who bought a car for $25,000, but the value is depreciating at a specific rate of 10%, and we want to know how long it would take for the car to be worth $15,000. So if you remember, what we did is we set up our exponential decay formula, and our final amount is going to be the 15,000. Our principal, or our starting amount, was the 25. Our rate was 10% as a decimal is 0.10. So what we did is we put the left as y1 and the right as y2, and we went ahead and graphed. So you have that horizontal line along with that curve. We found the intersection of those two functions, and that's how we would get our answer, by looking at the x-coordinate. Now, the other way that you can do this using logarithms is still have that same setup as we did before using our exponential decay. Now, you would have to simplify. So we divide by 25,000. We would also simplify inside my parentheses, which would get us 0.9. In order to rewrite this exponential, I like to have the exponents, whatever has our variable, on the left-hand side. It makes the loop a lot easier to do. So I'm just going to rewrite this as 0.9 to the t is equal to 0.6. What I can do is then do my loop. So I would get the log and then our base of 0.9 of our argument, which is 0.6, is equal to t. We got our exponent out. You can go ahead and do your change of base formula, which would then simplify to 4.8 years. So we did get the same answer at the beginning of the unit when we found our intersection of those two. So in these two ways you are able to do either one in order to answer these questions. Now, here are some things for you to remember. Don't forget the change of base formula. So we can actually go ahead and calculate the log. You are able to go ahead and use that log base option under the math menu. And don't forget to loop around. In order to write your log, you want to loop around that exponential equation. So I hope you found this video helpful. You're able to solve exponential equations using logarithms. Thanks for watching and see you next time.